Well, let's talk about the idea of similarity. So, similarity refers to the cases where two figures have the exact same shape but may be sized differently. So it's just like a case of enlarging or reducing an image. It can be made larger or smaller, retaining the same or shape but have a different size. So in terms of geometry, we say that two figures are similar if all matching angles are equal and all matching sides are of the same ratio. So this is a somewhat more rigorous definition than just saying same shape. Well, what's the same shape mean? Well, it means that all matching angles are equal and all matching sides are of the same ratio. What does this actually look like? Well, let's have an example of, say, two rectangles. Say, the first one, let's say it's 5 wide and 20 long. And now a second one. This one's 10 wide and 40 long. Yep. Of course, if they are both rectangles, means all angles are equal. And then, so all matching sides. So this angle and this angle same, this angle and this angle same, this and this and same, and so on. Apologies, the battery on the camera ran flat as I was recording the last segment. Well, let us continue on with this example. Yes, the 40, the long side matches with the long side, short side matches with the short side. So we can try to find the ratio between the two triangles. So here, the ratio between the long side, 40 divided by 20, 2. The ratio between the short side, 10 divided by 5, is also 2. So this means they are similar because the ratio of matching sides are equal. And this ratio here is sometimes also called the scaling factor. So basically, how much the first diagram has been scaled. Now, let's have a look at another example. So for sometimes you may notice that, let's have two rectangles once again. Side length 12 and 9 and a small one. And 3 and 4, let's call this B. So in this case, even though these two rectangles are oriented quite differently, we still can say that we can still examine whether they're similar or not. Notice that matching sides will be the long sides, the 4 here, 12 here, and the shorter sides, the 3 and the 9 here. Once again, short side over long side over the long side, yeah, which equals, of course, a third, and the shorter side over the shorter side, which is 3 over 9, once again equals a third. So the ratio between these two triangles is 1/3, or as I say, the scaling factor of 1/3. What can we use this information for? Well, let's have a look at something rather contrived. So a triangle. Length 10, side length 8. Yeah. And another one. Of course, it's not drawn to scale, otherwise it would be too huge. 48 x here. As we can see, these two are meant to be similar, but we don't know the length of this side. What we can do is we just match this the long side over the long side, so 48 over 8, which is 6. Well, and the x over 10. You see, if they're similar, then the matching sides have the same ratio. So the ratio between this side and this side should be the same as the ratio between this side and this side. So should also equals to 6. And as we do when solving equations, we multiply 10 by both sides by 10, and we end up with x equals to 60. So that's pretty much it.